Hello everybody, this is a review for Module 10, Phanerozoic Biota. In total, it is over 8 hours if we look at the lecture, but I'll try to summarize all of it and cut through all the fluff. So, yes. So, in this picture, just test your knowledge, see what kind of organisms you know. This might be on the test. This is a crinoid. There's a trilobite. There's a. I thought this was a mollusk at first, but he said this is a nautiloid. In this picture, this is a breakdown of what the late Cambrian looks like. The North America is in the middle. It is theorized that there must have been a continent here. The white line represents the modern landmass, and this represents that this might have been flooded. Most of Asia, Antarctica, or Middle East, Asia, all of that other continents is here. Our prof suspects that there was no subduction zone here, and there was a continent that sunk here. So this is the Middle Cambrian. The outer represents the shallow or deep water deposits, and then in the inner parts is the terrestrial area. In the late Cambrian and Middle Ordovician, most of the continent was flooded. So we might get tested here. Most of them are limestone. This picture specifically is from the Triassic, and there's a variety of fossils in it. We might, yes. So Joachim is talked about. Basically, just to summarize everything he said, he is a person who studied fossils, specifically trilobites, and engraved it in lithographic limestones seen here. And most of the fossils that is presented are brachiopods, such as this one, and trilobites. Here is another fossil of trilobites. Most of it are from the Cambrian. So, okay, fossils, this is just an exercise just to familiarize ourselves. So number one, we see a trilobite. Another trilobite. This image shows a fossilized graptolites, and this is a crinoid. I'm not sure what, I forgot what, I think this is also a crinoid. These two look pretty similar, but this is different. This is definitely a crinoid. This one I'm gonna have to double check. Guys, double check your labs. If you have a lab, look at the fossils on the lab, it will help. This another trilobite. This is a cephalopod, trilobite, and a crinoid. So another exercise, bivalve trilobite, a cool rock, as he says. He doesn't even know what that is. A fossil frog. This is a ammonite, and this is a Cretaceous sandstone from fluvial deposits. So try to name the organisms, try to test your knowledge. We'll go through it right now together. Trilobite, jellyfish, which is what family are they from? Gonna have to review. If you don't know, algae, and some sponges. So this graph just shows you a extinction and appearance of species of organisms. So this represents, the red line represents each of the species. The length represents the width, or how much that species persisted. Um, as we look at my notes, a common pattern noticed was that there is an explosion of organisms and then there is an extinction afterwards. So big explosion and then an extinction and then it picks up again and then it crosses over and then it becomes extinct. That is a common trend. Sorry for this. Other fossil groups at this time except the trilobites did not show this pattern. Okay, this is what I have interpreted from the lecture slides. Okay, so memorize this: causes of diversification, adaptive radiation. Memorize what the cause was in the physical, intrinsic biotic, extrinsic biotic, and know them. We'll go through them quickly. Physical, new habitats, new environment. Intrinsic, they disperse quickly or slowly. Environmental tolerance. Genes that are different, genetic variants. Extrinsic biotic, new food sources, immigration of other species. Evolution, competition, predators, and yeah, just try to know what they are. Okay, so I'm not sure if he will ask on the test, but just to be safe, I want to break everything down quickly and precise. So the GOB is the Great Ordovician Biodiversification Event. Basically, the lower Ordovician diversification is slow and then ramps up the diversification in the middle Ordovician. The rocks, I will try to break down the rocks just in case he asks. This is a thin bedded limestone, mound patch reefs. This is small patch reefs, and the date is early Ordovician. Okay. So this fossil is a greenhead reef complex. This is in the beginning of the Ordovician. If you don't, please check your time scales. If you don't know if you're not familiar with these terms, Ordovician, Cambrian, those stuff, check the time scale. So let's try to go and name them together. I think this is a calcareous algae. I'm not sure. I need to check myself too. Nautiloids. This is a nautiloid. This is a snail or it's a cephalopod. This is a sorry. This is a deposit, a bunch of like sand deposited here, and some of them are burrows. Yes. Okay. So this is a cross section. This is a coral, brachiopods here. He mentioned a trilobite. I don't see them though. This is a sponge spicule. Okay. All right. Another exercise to identify, test your knowledge. This is a nautiloid, trilobites, another trilobite, a snail, bryozoan, brachiopod, rugose, coral, K. This is a clam, G. Let's see, let's look at our notes. F is, I think, is a clam too. Yeah, oh no, it's a brachiopod, sorry about that. And then J is a calcareous sponge, stromatopoloid. I is a tabulate coral. So this is a tabulate, and rugose tabulate is it is colonial. Rugose is solitary. We talked about it in our labs, but just a quick refresher. Look at your labs. If you have a lab, and if you don't, please refer to the textbook. It will tell you all about it. Okay, so Basically, this is James Hall. He wrote a bunch of brachiopods. Okay, so this middle is an alloid. If you see this, this is an alloid. If you see some kind of pattern like this, an alloid. Um, I thought this was a mollusk. He said this is an alloid. I'm not sure. We're gonna have to look through and review it, but that's what he said. Double check. So this is an alloid. These are cephalopods, and this is a stromatopoloid. Okay, another picture. This is a trilobite, snails, bivalves. Okay, so these are brachiopods, and this is a Devonian bed. And then you can see that this is a coral right here. These are corals, conical corals, the stump of it. And okay, next. So let's try to test our knowledge. Sponge, crinoid, trilobite here, a nautiloid somewhere here. This, yeah, yes, this right here is a nautiloid. These squid-looking things. I thought this was a mollusk, but it's a nautiloid. And this is a receptacle, sponge receptacle. Okay, next. So this is a Gull River Formation middle ordovician. These ripples represent, like these dimples represent the waves, and this is a brachiopod on the rock. Simple. Okay, here's another one. There's a nautiloid here. That's a brachiopod for snails. The green color represents the iron that's in the clay. Don't confuse them with the red one. It's totally different. Okay, next. So the patterns that you see a lot are burrows. On the right, this is an alloid. And the greens are minerals that transformed. Okay. Okay, so this is an alloid, trilobite, bryozoan. Where's the bryozoan? Man, even I don't know. Okay. But test your knowledge. Try to see if you can name them. So, interpretation of this map. Baltica and North America squished together. There is less flooding in the late Ordovician. Yes, no, sorry. There is flooding in the North America and the shallow seas. And Baltica and North America collided. There's no subduction zone. Okay. So, interpretation of this. You see that this right here, this is the limestone, and then most of it was replaced by the shale because of the collision from here, right? So when that happens, shale sandstone replaces this right here, goes over it, and then what happens here is that Cambrian to Ordovician is a passive margin, and the upper Ordovician is the active margin, and then it has a foreland basin. Should put that as a foreland basin, and it causes the uplift and erosion here, and the mountain belts come up because of that collision. Okay, here's how they collided. So this is the passive margin in this map, and then you see that the Avalonia volcanic arc right here, it collides. And then here it is in the late Ordovician. Okay. Alright, so what this image represents is the foreland basin advancing westward. So when it collided, it had the ripple or the flish, and the siltstone, sandstone comes up, and then it causes the carbonate platform to bulge, to produce an unconformity, which is seen here. And hopefully you have some idea of how this works in the lab. We've talked about it. Hopefully you guys understood what happened. If you did not, please look up um, look it up on the textbook of the rocks, how they interact and everything. If you are in 109. Anyways, okay. So here's another interpretation. Collision of Avalonia and tectonic mountains is called orogeny. And then in the Queenston, Ontario, Toronto Hamilton has a lot of bricks because of this. And Saskatchewan has a lot of evaporites and was dominated by limestone. And then it got covered because remember, Saskatchewan area used to have a lot of marine life. And if we go back to the lab, most of the things we looked at the Devonian had a lot of trilobites, crinoid, shallow marine life area. And it was in the limestone, and then it got covered by a bunch of things because of the rifts and all of that. Okay, I will not get in too deep like he did. Let's move on. Okay, so this is the interpretation of the well. This right here is the corals and the fossils. This black thing right here. And then here, there's barely anything here because it turned into dolomite. And then what happened is that it became anhydrite. It evaporated. It evaporated. And this right here just shows you the cycle of anhydrite. It was really hard to interpret what he was saying, but this is the best explanation that I got from it. Okay, let's move on. Let's not waste any more time. Okay, this is just a visual overview of the major events. I'm not gonna go through everything, but make sure you understand what it is. Like, if there will be questions about, oh, where was the trilobites? What was their time scale? Obviously we all know that trilobites are in the Cambrian, and then they sort of disappeared in the Devonian or Ordovician. Sorry, yes. Yeah, just try excuse me, try to just look at the summary. Okay, next. All right, so we see this map. So basically, I'm gonna try to interpret this. This right here is the top of the Ordovician, the patch reefs, which is right here. And then this is the thin bedded limestone, just in case he asks. And on top of that are the newer rocks. Okay, let's look at our notes. We see the world get cold due to change in oxygen levels in the late Ordovician before returning to normal levels at the very end. Mass extinction in the world during this glaciation of Gondwana in North Africa. The carbon cycle changes because of carbon being buried and consumed. This is basically what it represents here. Okay, let's move on. Causes of regional extinction, species and lineage. Again, please look this over. This is something he might ask, like he asked on the midterm, what are the causes of, what was that question? But it was something like this. He asked a question that we know, we have to know because of this, and I put bathymetry in that, and there were, and it helped out. So please review it. Same here. Review the causes of global mass extinction, species and lineage. Review this. Try to review it. I'm just trying to interpret the ones that I did not understand, but we are all smart enough to understand this one, but I'm not sure. I will try to help out with understanding these images, but stuff like this, review it. Okay. Again, mass extinction, please review it. You have it, review it. I will just go over the images. Okay, so the Silurian diversifies again to a biota sorry, the biota diversifies to a positive steady rate in the Silurian. Glaciation from late Ordovician melts and the world goes back to normal. Silurian biota diversifies and it starts with snails, brachiopods, and corals. Okay, so this is the Niagara Falls in the Silurian interpretation. This is it now. Niagara Falls is an example of early Silurian rocks. Carbonate platforms is here, and if you go downstream, the older the strata is. Okay, and all the fossils that includes are the chironoids, sea lilies. It represents a high energy event that deposited them bivalve swarms burrows. Oh, what is this? Put that away. Okay. Next. So this is the shallow marine carbonate rocks turned into dolomite. This right here, he might ask you. I'm not sure. Just want to make sure. This is an erosion right here. And then if you go downstream, if you go down, you will see a dolomite. And then you will see the iron-bearing shale sandstone offshore bar. That is a mouthful. But yes, this is what it is. First version of avalations in the late Ordovician eroding down, so it erodes down. The bottom rocks erode laterally, typically of shallow marine and offshore settings. So just try to remember that it erodes in shallow marine and offshore. Okay, and it erodes laterally. Okay. So this is the rocks in the Niagara. We will try to go over them quickly. These are crinoids on this brown rock, and then here is a fine-grained fossil, bivalves and mollusks right here, and you see this has a wave in it. And then the lower right, the burrows, creatures burrowing here in the silt and mud, living in the Silurian, and lower left is rippled sandstone bed with the U-shaped burrows in the sand and the mud. Most of the rocks from Toronto are from the quarry, according to what he said. Okay, next. So another exercise, can you name the organisms here? This is the Devonian. Devonian's kind of the same as the Silurian. And a few diversifications. Okay. So this is what the early Devonian looks like. The map. Laurentia and Southern Europe squishing up against Gondwana land, which is the main continent. Okay. So basically this is what I got from 15 minutes of what he said is just this. Laurentia and Southern Europe squishes up against this. Okay, move on. Alright, so there is actually a lot here. I will try my best to break it down, but okay, we'll see. Okay, upper left is a brachiopod and theropods. Lower left is a stromatoporoids, calcareous sponge. Warm fluids penetrated the rock and turned into a diatomite with high pressure. Lower right is a wall of corals and stuff. So there's massive sponges. Oh, okay. Yes. Okay, so now we look at this mountain. So in this area is a patch reef on the bottom, and it has many fossils in this area right here. This right here. And the extinction event is on the top right here, which we will see later for the history and timeline of these rocks. So in this mountain it has a massive sponge, corals, fishes, nautiloids, shells, brachiopods. The reefs are an oasis of diversity. Oil is discovered in a lot of the upper Devonian rocks right here, but just know that this is the limestone, and it's a patch reef, and it contains many fossils. And then the extinction event goes up to the top, right there. Okay. So in page 46, this is what it looks like. The timeline. You can just tie it into this mountain right here. So hold on, sorry. So okay, in this interpretation, we see at the end of the Phoenician and one in the early Flaminian, there are extinctions. You see this? This big drop right here is basically an extinction. It's a big cooling and frozen. Everything freeze. It's hard to find fossils in these rocks caused by global cooling. The dips mean it got cooler and the diversity dropped. It is theorized that this phase is the extinction. And check 43 for the mountain, which is right here. Okay, so this one, the interpretation of this map shows that the late Middle Devonian here and then the late Devonian here. Okay, initially it was internal and has a lot of shales, and then it had reefs and an Elk Point Basin, which is right here in Alberta. There was an arcing crust and tectonics that caused compression. The sea became constricted and had no flow of marine. It had potash, that has potash down the stream, which is right here. It has a lot of potash. And then in the late Devonian, there were basement faults that look like the Bahamas. Yeah, so basically this become into this. That's basically everything he said in that 10 minutes. Okay. So this is evaporitic potassium from the Elk Point Basin. This is what he's talking about, the one downstream. Okay, so now we look at this image, and this is a pattern, basically like the one earlier, from earlier. Remember the, you know what, I won't go down, I don't want to waste time. But the pattern you see is that there's a big explosion of organisms, and then you see this kind of steady, and then a big dip, a big explosion, big dip, big explosion, and then a dip. And the recovery happens in the Mississippian. There's a big dip, and then explosion, big dip, and then a lot of diversification in Jurassic, Triassic. Right here, see a lot? Yeah, it's a lot. Okay. So, crinoids, bryozoans, this right here, in the early Carboniferous, we see a recovery of life on the top of the mountain. Like, remember the one in the Banff one, the picture? Yeah, so we see this, these types of crinoids and bryozoans and brachipod. This is a crinoid. Where's the bryozoan? It's not here. And then it has rugose, tabulate, and fish. It's very diverse. That's everything I got without the fluff. Okay. So rugose, tabulate corals right here, and this is what type of coral is this? This is the rugose and yeah, okay. I think they're basically kind of the same corals. Just know these images for the exam. He might ask you, you don't know, you know. So just try to know them. Okay. Early Carboniferous. So reconstruction of early Carboniferous. This is what it looks like. He might ask you what this is. Do you know what that is? It's a crinoid. What's this? It's reef fin fish. No, might ask you that. We don't know. Okay. So this chart is basically the extinction and origination of genera, and you see that both of them were kind of matching together. The extinction and the origination, like the pace, it pace together, right? But then the ice age happened, and then you see a lot of the extinction happen. It outpaces the origination rate from the Devonian, early late Carboniferous, and then the Permian, big extinction after the ice age. Okay, so know these images. There's a crinoid, there's a bryozoan, there's a sphinctozoan sponge. There was a question in the midterm actually. It asked it was the last one. It says, "Oh, what is this? Is this an embryo or is this a algae?" Then I put an algae because of that one image I remember from his lecture, and it helped me. That was one mark. It helped. Yeah, just be careful of the images, you know. Okay, Permian Reef complex right here. So basically, this is a carbonate platform, and then towards the end of the Permian, it was filled with gypsum, salt, and potash from the evaporation. So this kind of mimics the Bahamas. You see, this is the Capitan limestone right here. These are older rocks, and this is the Bone Spring limestone, which is right here. You see, in this mountain. Uh, Maybe this is, yeah. I don't like the way he lecture. He's okay. His lecture is no good, no bueno. So I think this is most of what he said. Yeah, this is basically it. Just try to know all of these. Maybe if it comes up on a test, you know how to identify them. You know how to, you know. Okay. So this end of the Permian extinction. You know, there's really not much here. It's just basically again the dips and the rise and dips, Permian extinction and stuff. Okay, so this is a spindle diagram. This is very confusing, but basically what the spindle diagram means is that you see this length, that width of the bar is a measurement of the diversity of the group, and then this length right here going up and down, that's the the how much it persists. Yes, okay. So this is a spindle diagram. The wider it is, more diverse. Okay, this. So here is a spindle diagram of these groups right here. Okay, moving on. So this is what the late Permian looks like. The late Permian has a big continent Pangaea, and then it was all tied together. So how this affects the creatures is that hold on, sorry, did I put it here? Okay, so how this affects the creatures is that you see this, it's closed off, right? All the marine life, there's a lot of terrestrial life here, there's not a lot of marine life, and it affects the creatures, how they evolve and everything. I think that's it. That's what I got. You can look at the legend, you can try to interpret the map yourself. I think you're smart enough to do that. Okay. Yeah, basically, you just try to look at the map. You can interpret it by yourself. I don't really need to break it down. He tried to break everything down. I understand it. Okay. If you don't, just pause the video. Try to understand. But yes, okay. End of Permian. All right. So just try to know what caused the end of the Permian. It's all right here. All right here. Just try to know the cause. End of Permian. Okay. Oh yes, and the red beds mean sandstone. I don't, just in case he asks, oh, what's the red bed or whatever. It's a sandstone right here, the red beds, the rocks. Okay. Alright, so this is the Red Canyon in Wyoming. It's a hot Permian and marked by a little moisture of the Triassic, and it becomes much wetter, switching back and forth from marine to non-marine. So you see these are the regression patterns you see. That's the regression. Okay, all right. So it goes from chug water formation and buried here, and then it has a gypsum spring, and then the Sundance formation, and then the marine transgression. That's basically what it is. And you can read the notes here, pause this video, read the notes. Okay. So rock record at Capitol Reef. Let's see how many slides we got. Oh, it's not bad. Okay, we can go through it. We can go through a lot. Okay, slide this. Sorry. Okay, so this is just the rock record. You know, pause this video. The Navajo sandstone is the one we got our first question in the midterm. Also, it goes from I got the question wrong, but if he asks another question like that, it goes from right to left. The wind blows from right to left, or in a clockwise motion. It goes in a clockwise direction. So if he asks another question like that in the sandstone, you know, okay. But just pause this video, try to see what the valleys are and everything, see what this is, and try to interpret it yourself. He did not give a lot of value on this slide. I don't know what he talked about, but you know, okay. This is the Navajo Park. There's really not a lot here either. It's just he talked about the limestone, the stratigraphs, the sand. This is basically from shale. It used to be shaly and marine life, but now it's not, and you can see why. Because look at these the stripes right here. It shows that there's regression and transgression here, and this used to be underwater, and there used to be limestone at the bottom, and then you know covered in sand and everything. All right, okay. Next. All right, so this is the late Cretaceous, little similar today. Only difference is this, I think. But yeah. So you see this wind blowing this way, and so let's try to look at my notes. Continents in very roughly similar place today. We have North America, seaway splitting North America in half with water. Oh yeah, the Panama Canal is here now, right? The modern one, modern map. But before it wasn't there, so it goes whoosh, straight. Tethway seaways, tropical sea that created lakes all over the Middle East after, and then it rained. Oh yes. So the Middle East used to have a lot of lakes, and then now we see it has a desert, right? Middle East is a lot of desert, but yeah. See this? Arabia used to be covered in shallow water, shallow marine life. Okay. Okay, so we look at these. Mesozoic through Cenozoic, you can read this, you can understand the information. I will not talk a lot about it, but there basically is a diversification in all of the marine life. And image E was diverse, and it went extinct. This right here, what is this? Cephalopod was diverse, and then it went extinct at the end of the Cretaceous. Okay. So just know these images, pause this video, look at the images, know them. I might ask you what this is, or what is this, or what's that? You know, you don't know. Not Lloyd. Okay, next. Ammonite. All right. Okay. There's a gastropod. Most are from Cretaceous. Let's move on. Okay. There's a giant coral. Belemnites. Some gastropods. Ammonites are offshore creatures found in shallow marine environments and preserved in limestone and sometimes shale. So this is an ammonite. Okay, let's move on. This is an outcrop in Oman. These are thick shells, concycle bivalves with a cap and partly coiled. These rocks look similar across the world, and they were formed in Tethys Sea, which is around here. Where's Tethys Sea? Okay, I'm gonna have to look that up by myself, but yes. Okay, next picture. Just know these. Oh, this is a dimension stone, by the way, just in case, you might ask. Okay. So the diversification of plankton, and this basically what I got is that the straight ones are benthic, and the coiled ones are planktonic. This one. And diversification of planktonic and benthic forefibers. They are source of um, carbon calcium carbonate, and they have green algae too, and that causes change in the carbon cycle. Okay, let's move on. These are single-celled amoeba-like protozoans, and it has the shell. Okay, moving on. So this is a chalk, coccolith coccolithophores. These are like green algae in the carbonate mud chalk. This is basically it. And then you see this round thing. These calcite precipitate, and it fills out the pores. That's basically it. Okay, next. So this is just distribution of chalk in the Cretaceous. I don't think we need to go in depth. It just shows you right here, and we went through it. If there is shallow transgression, the deep means it's chalky limestone, and then if it goes up, it regress. It's shale, and then shallow again. It shows here. Okay, next image. Same thing. Cycles of regression and transgression. This is the sand. That's the shale right here. Yeah. Okay. So the Cretaceous was much warmer than the modern world.